So we'll go ahead and start recording. Let's fire that up. Web apps, there we go. So web apps, plugins, scripts, and APIs. We'll cover, it's kind of a catch-all. These last two YouTube lectures, there are going to be a lot of things that we brought in that we haven't covered yet and we want to cover before the semester's over. Okay, so what we'll cover first, web apps, and then we'll start talking a little bit about plugins. So browsers as video players. If you go to YouTube, of course, you see a whole array of links to videos, and clicking on any one of them takes you to a page where that video plays. So in essence, what happens, your browser is acting like a video player application for each page. Now, this is an interesting thing because the browser fundamentally was not originally designed to be a video player. So how does YouTube manage this, considering things like different hardware configurations, different operating systems, different browsers and versions, right? How does it automatically recognize what sort of device you're using and what video content is appropriate for that? And how does it reformat it or otherwise make it available to all those different possible types of hardware and software? I don't know what that was, but that was a disturbing noise. Oh, we got chat. What's happening? You can't see the screen? Oh, I'm sorry. My bad. Thank you. Here we go. Well, it'll be there in the video, I think, I hope. So there we go. So YouTube videos, right? We're covering web apps, plugins, scripts, and APIs. Okay. So essentially, yeah, the browser acts as a video player, and YouTube has to make sure that whatever kind of browser is running on whatever kind of machine, it gets an appropriate kind of video that can actually be watched. Originally, what happened, the way YouTube dealt with this, so circa 2005, YouTube stored the data for videos, but you needed some kind of separate video playing application to actually watch them, right? So something like Flash Player or, you could have QuickTime for Apple, and there were other ones out there. But nowadays, YouTube videos are shown as HTML objects, and you don't need a separate video player application. The browser can actually just show them natively without having to forward the data to another application. So big questions, how did this happen? What technologies were required? And why did it happen? So this is the great mystery we'll have solved by the end of this lecture. And it starts with the basics of what is a web app. Well, a web app is a client-server application that runs within a browser window. And typically, a web app runs online, but potentially can also run offline. So anytime you have some kind of application that runs within a browser, right, that runs basically on a web page, yeah, that's a web app. And the implications of all this, number one, most web apps assume that the devices running them have limited storage and computing power. So they're typically designed as thin apps for thin clients. If you remember what a thin app is one where the server does most of the work, not the client machine. And a thin client is, of course, a relatively weak machine. So think of, again, any app that's not going to be too demanding on the device and is most of the work is going to happen on a server, not on your actual machine. So something like Facebook. Facebook does all the work of determining what's in the feed, and then they show you what's in the feed, right? That's not all happening locally on your machine. Number two, web apps expect different hardware, right? You could access the internet with desktops, tablets, smartphones. All of those could have different operating systems. All of those could be running different browsers. So the web app has to be reasonably compatible with all of those. And last, in most cases, you want your web apps to tolerate problems like disconnects or traffic surges that temporarily make it difficult to send through a lot of data. Because what you don't want is to have some kind of web app that somebody's using in an area where they're frequently losing connection, and every time they lose their connection, they have to go back in through the login process and try to find where they were at whatever point in time they lost connection. It'd become a big hassle and people would stop using it. So generally, web designs are designed to tolerate that sort of disconnect. They'll hold the state of your situation in the browser until you restore your connection. Okay. Now, difference between web apps and web pages, right? So all web apps are going to run on web pages, but not all web pages are really apps. So they're closely related, but not quite the same. So both of them are content displayed in browsers, and it's going to be retrieved from servers via an internet connection typically. And a web page or website may exist to run one or more web apps, right? So, for example, you go to facebook.com, there's a bunch of apps that are accessible there, right? There's the instant messenger, there's photo upload, there's whatever games and random quizzes and whatever else you're doing on Facebook. All those things exist there. So Facebook, although it's a website, it's also a platform for a bunch of different web apps. But here's the difference. So web page holds all the content. It might not even be dynamic, right? It might just be all text, static images, and nothing ever changes. But a web app lets the user do something, and therefore it needs dynamic content, right? If it's not an app, if it's an application, the user can do something with it. And by doing something with it, we mean there's going to be some sort of dynamic content on the page. Also, web page might contain one, multiple, or no web applications, right? We give them the case where it stores none. If it's all static content, we've given the case where it stores multiple ones like Facebook. And of course, it might just have one, right? You might just go to a particular page and there's the one app there and that's it. So again, web apps run on web pages, but not all web pages are going to have web apps. Next step, dynamic content. So the web application has to exist either on your local machine or on a remote server, right? The application has to run somewhere. It's either going to run on your machine or it's going to run on a remote machine. Because of that, there's two basic methods for running apps in web browsers. One is the plugin. In the plugin case, you actually run the code on your machine, right? You download and install some application on your machine, and you run it in conjunction with your browser. For example, Flash Player was one of the big plugins of the last 15 years. The alternative is scripts. Scripts, there's two kinds. There's client-side scripts that run locally on your machine. There are server-side scripts that run on the server machine. But either way, you can embed those instructions in the web page that retrieve any dynamic content as it's needed. And we'll talk about all of those. So, early stages of plugins. Well, way back when, way back when, like circa 1995, web browsers only supported static content like text or unchanging images. So even basic things, here's a simple example of how primitive these things were. Way back when, we had a thing called AOL, America Online, and we were glad to have it. Okay. America Online, circa 1995, 1994 even. And up in the upper corner of your screen, there'd be a little mailbox icon, right? It looked kind of like, I'm going to draw it real half-assed. Dun-dun. And if there was no mail, so I'm going to say, here's your mailbox. And if you had no mail, then it was boring and looked empty. But if you did have mail, there's a little flag up there and a little circle with a little red fill-in on it, something like that. And you'd get the happy announcement, you've got mail, which is kind of analogous to you have friends, or somebody out there likes you, something like that. It felt very good in 1994 to get email from people, not like now where we have more email than we really want to get. Okay, but the neat thing about this, because in 1994 dynamic page content wasn't really a thing, you only got the notification when you loaded the page. So if you wanted to check the status of your mailbox, you had to reload, maybe many times. Okay, this was all before something called Ajax that allowed partial uploads of refreshes of parts of your page. Nowadays, of course, you can go to Gmail and new emails will automatically become visible without any reloading. Okay, but back in 1994, this was how it worked. If you wanted to see if you had email, you actually had to reload the page, and there could be a whole bunch of email piling up in your mailbox, but you wouldn't see it until you refresh that page. Okay. Of course, people like dynamic content, right? People like those kind of real-time updates. People like browser games. People like other aspects where real-time updates are important. So people started developing plugins, separate applications that help the browser display additional content types, quite often of dynamic data. Now, the big early technique from the late 90s to the early 2000s was something called the applet. So an applet is a small downloadable Java application that runs in a designated box on a web page. So the early ones, whoops, that's not what I wanted. One of the early ones, one of the last ones to survive in the wild, was on a site called chess.com that you may have heard of. It exists. Okay, so chess.com used applets to play your games, right? So somewhere here in the box, you know, it would define, there would be an HTML tag that basically said applet ... and then close out the applet. And it would bring in this little box of a chessboard, right? So let me show you what it looks like. Let's doing some stuff here. Chess.com board. So it looks something like this, right? Except it wouldn't be this pretty. It would be like more like black and white. But basically, any one of these little images here is what you would see when you went to chess.com, right? Something like this is probably about right. Yeah, something like that. So there's a little rectangular application running in your screen, and that was great. So where are we here? Anyway, because they were written in Java, they could run on any machine. Java is a universal language that essentially you write the program and it automatically gets translated through something called the Java virtual machine to run on whatever kind of hardware configuration you have and whatever operating system you have. Short version there, Java is a universal language. If you take IDS 201 with me, you'll learn a whole bunch more about it. The problem with applets, and there were some problems, number one, weak aesthetics, and number two, security vulnerability. So they didn't look that good. I mean, they were fine if you kept it in the same size rectangle as it was designed in, but if you tried to change the size of that, it got all pixelicious. And the other side is that there were security vulnerabilities. We'll talk about those a little down the line. But right now what I'm going to do, I'm going to talk about the image quality problems. And then we'll call it a day, I think. I think we're at a good point. So, image quality issues in Java applets. Okay, so one of the problems with Java, because Java is a universal language, it tends to not use advanced graphical features. Instead, it uses simple graphics that it knows can run and be, you know, viable on any Java-capable machine. Okay, so it's specific like some others, but it's universal. Any computer language, any operating system can show little windows of graphics with pixels, but certain other techniques, yeah, they might be a little bit more difficult to implement on multiple machines. So this meant when you expanded an image or contracted it, when you expand or contract an image, there will be just simple multiplication or division of pixels. Okay, so let me show you what I mean. If I draw a nice image, let's see, I'm going to draw something here. Let's draw an arrow. Okay, if I take this arrow and I zoom it, let's see how that goes. it starts to look a little blocky at the edges, right? You can see that if you like really zoom in on it. You can see that it starts to look, oh yeah, I can definitely see some, you know, some rough stuff at the edges, right? Similarly, if I write in a little bit of text, at this point I'm just using the pencil. So if I write in, say, the letter lowercase b, okay, that's a passable b, I suppose. If I expand it, it starts to look blocky, right? It starts to look, the technical term, pixelicious. Okay, so in Java, zooming leads to pixeliciousness, which is considered bad, okay? But your more advanced graphical styles, they did something called smoothing. So if I take this image, which is basically a different kind of graphics stored, you'll see even though I zoom in a bunch, it still looks pretty much like a bee, right? Basically what they're doing here, even though this still gets a bit pixelicious, right? You can definitely see, yeah, there's some blocky chunks around the edge. It looks better to most viewers because why? Because it uses what are called fractional pixels and partial color maps. So, for example, on the left here, the left of these expanded pixels, I see a little bit brown. On the right, I see a little bit of bluish, right? So, for example, here, brownish to the left of black and bluish to the right. Anyway, and especially this looks good. This is especially important for videos or games where there's motion, right? In which case, this sort of stuff, this sort of fuzziness around the edges, you're in many cases not going to notice it. As things are moving around the screen, things are going to be a little bit blurry anyway. Whereas this kind of pixeliciousness is going to be pretty noticeable. Okay, so that's it. So the big thing was because of these graphics, right? You could do better graphics with without applets with some of the other plugins. And so plugins eventually fell by the wayside. But security was another problem. We'll talk about that next time around. All right, so I think this is a good break point. We made a little bit of a dent in this. We got enough stuff to talk about next time. That's good. Okay, questions on any of this stuff we covered today or other general things about the course? What's happening? Nothing?